In Chapter 5, if you've watched Dr. Mosley's videos, he talks about the difference between discrete and continuous random variables. The discrete random variables are when our data deals with countable number, for example, the number of people in a car. The continuous, which we'll talk about in Chapter 6, deals with countless measures forming a continuous data set, like the time it takes to drive to school. Most of the time you can distinguish these discrete by it says the number of. So it can only be 0, 1, 2, 3, 4. It can't be anything in between. So in Chapter 5 we talk about discrete random variables. We are going to go directly to section 5.2, but in 5.1 it goes into a little more detail of what a probability distribution is, and that's where it lists the different possible values of our random variable and their associated probabilities. You may want to just skim over 5.1 to get an idea of what a probability distribution looks like. Now, when we talk about in 5.2 a binomial experiment, it's dealing with when we have two possible outcomes, and we call those either success or failure. We have a fixed number of trials, which is n. They're independent. We have success or fail. Probability of S is the same for each trial, and we usually want to find the probability of R successes out of n trials. So we want to go directly to an example for this. There are, when we calculate the binomial distribution, there are really three different ways that we can get each probability. We can use the formula, which I think Dr. Mosley shows you a little bit in his videos. We can use the table in the back of the book, or we can use our calculator. And I'm going to show you in this example how we use our calculator. All right. This example is a doctor tells you that 80% of the time a certain type of surgery is successful. If the surgery is performed 7 times, find these values, and then we have some problems asking it. So, if the surgery is performed 7 times, that is the number of trials we have. So n equals 7. The probability of success is that it is 80% of the time the surgery is successful. So our p, generally this probability of success is shown as a percent, but we want to write it as a decimal when we assign it to p. So p is the probability of success, q is the probability of failure. So q is always equal to 1 minus p, because remember the sum of our probabilities always equals 1. So in this case 1 minus 0.8 is 0.20, and then r is going to be assigned for each problem. Alright. Now when we set up finding the probability, 2 things you want to always do. Always set up a probability statement, okay? And that will help you determine what you're putting in your calculator. So the probability that exactly 6 surgeries will be successful, when I set this up as a probability statement, it's the probability. I'm trying to find the probability that R, when it says exactly, that means equal. Exactly means equal. So probability that R equals 6. Okay? We're going to look at part B just so you can see the difference here. Part B says we still have to calculate part A. The probability that less than 5 surgeries will be successful. Well, less than 5, you want to write these as inequalities. So in your textbook there is a page that actually goes over how translating English phrases into inequalities. So you want to practice that. The probability that less than 5, that's that R is less than, so it doesn't include 5, right? And that's very important in binomials. Okay, now, when we go to calculate these using the calculator, we can either use the binomial PDF or the binomial CDF, okay? The binomial PDF only applies if it's equal to something. The binomial CDF applies everything less than or equal to that number. It's cumulative. Cumulative CDF. Okay? So on the binomial PDF, on our calculator, what we do is where we find both of these is under the distribution key. See how it's above the vars key? So we do second distribution, I'm going to go, whoops, all the way down. So you got to scroll a little ways, and you'll see A is binom PDF, B is binom CDF. I'm going to choose A because PDF is exactly equal to, and that's what I'm finding here, binomial PDF. Okay, so I'm going to write down how I put it in my calculator. This will help me on the tests to see if you made a mistake. It's easier for me to see where it is to give you partial credit. So what we put in is the number of trials, comma, the probability of success, comma, R. NPR is how we put it in our calculator. Now, some of your calculators will look a little different than this in that they will ask you number of trials, probability of success, and then hit paste. Okay? So on mine, I have to actually put them in. So I put 7 is the number of trials, comma. Remember, your comma button is right here above the 7 key, if you need to do it this way. 0.8 is my probability of success, comma. My R is 6. So I put in my calculator 7, comma, 0.8, comma, 6, which gives me 0.3670. I would take these out at least 4 decimal places so you don't have any rounding errors. Be careful on WebAssign to actually put in what it asks you, or round how it asks you. Okay, now let's look at part B here. The probability that less than 5, we know it's less than 5. Okay, so the calculator only knows these two things. PDF, which is equal to, CDF, which is less than or equal to. This is less than. It's not less than or equal to. So I have to rewrite this in terms of what the calculator knows. So if you think about it, 0, 1, 2, 3, 4, 5, 6, 7, okay? These probabilities, what I'm looking for less than 5 are the probabilities of these 4 occurring, correct? So it means 0 or 1 or 2 or 3 or 4. Now I could do these individually using the PDF, PDF of 0, PDF of 1, PDF of 2, and add them together, and that's okay to do it that way. Or I can also say, well, less than 5 is the same thing as less than or equal to 4. Correct? Less than 5 doesn't include 5, less than or equal to 4. So I can say binom CDF, N is 7, probability of success is 0.8. Now my R for CDF, it's always what it's less than or equal to. So my R isn't 5, in this case it's 4. So I do second distribution, go all the way down to binom CDF, remember because I want 0, 1, 2, 3, and 4. I do 7, comma, 0.8, comma, 4. And I get 0.1480. So we have the binom PDF is equal to, CDF is less than or equal to. Okay, I'm going to do another video and do these last 3.